Hi everyone, welcome back once again to this channel. Today we're gonna start with your paper 2 from your grade 12 November 2021 past paper, and we're just gonna start with trigonometry, and that is your question 5. Okay, question 5, 5.1. It says, without using a calculator, simplify the following expression to one trigonometric ratio. Sometimes they say to a single trigonometric ratio. All right. So we are given sine 140 times sine 360 minus x, all divided by cos 50 times tan minus x. Okay, so how can we simplify this? So we know that in order to simplify this, we can actually use a reduction angle formulas, right? We can reduce sine 140, right? Probably let's first sketch our Cartesian plane. We know that's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and what? And 360 degrees. We know that all students take what? Coffee. So there it's sine, there's tan, and there's what? There's cos. So where do we get 140 degrees? So 140 degrees is between 90 and what? And 180. So that's the question you ask yourself. And how is that quadrant defined? It can be defined as 180 degrees minus theta or 90 degrees plus theta, because we are moving forward. We'll be adding a theta on 90 here. Because we are moving backward, we'll be subtracting one theta on 180. So I can simply choose this one to say, okay, I can rewrite sine 140 as what? As sine 180 degrees minus what angle can we subtract so that we can still get this 140. So it's definitely, it's gonna be minus what? Minus 40 degrees. Okay, so let's go there. Sine 360 minus x, we can reduce it, right? Where do we get 360 minus x? 360 minus x, it's actually found on the fourth quadrant, right? Because we are going back, we say 360 minus theta. All right, so in 360 minus x or 360 minus theta, we have cos, right? And here we are given what? Sine, meaning the answer must be what? Negative, because sine is not found on that quadrant. So it will be negative sine x when we reduce it. Okay, all divided by cos 150, cos 50 degrees. So cos 50 degrees, we know that is the same as what? As sine 40 degrees, right? Because those are cofunctions. So long as we add them, they give us 90. Or you can actually rewrite it to say, okay, where do we get 50 degrees? So 50 degrees is actually between 0 and 90, which is the first quadrant, which is defined by 90 minus theta. So it's to be cos 90 minus, what can we subtract? We can subtract 40 degrees so that it can be 50 degrees, right? So what is tan minus x? So minus theta is found on the fourth quadrant, because on the first quadrant it's plus theta, we are adding theta, but when we go back we are subtracting theta. So tan minus theta, it's where there is cos, meaning tan will be what? Will be negative, because it's not in its position. All right, so we can simplify this. What is sine 180 minus 40? It's where there is sine, so it's positive. It's going to be sine what? Sine 40 degrees multiplied by minus sine x. All right, all divided by what is cos 90 minus 40. Be very careful when it's 90 degrees, right? A lot of you might forget to change. Most people will just say cos 40 degrees and they think they wrote the correct answer, which is not correct. So 90 degrees is a cofunction, meaning that cos must change to what? To sine, right? Where do we find 90 minus theta? It's all of them, so the answer will remain positive, sine 40 degrees. All right, so what is minus tan x? That is an identity. We can change it into minus sine x over what? Over cos x. Okay, so sine 40 and sine 40 will cancel out each other, right? Then we'll have negative and negative will also cancel. Then we have sine x divided by sine x over cos x. All right, so if we change division into multiplication, we're gonna swap. Cos will go up and sine will go down there, right? Sine x and sine x will cancel and we are left with 1 times cos x. The final answer will be what? Cos x. So we have actually simplified the expression into a single or one trigonometric ratio, which is cos x. All right. 5.2, it says prove the identity minus 2 sine squared x plus cos x plus 1 all divided by 1 minus cos 540 minus x is equals to 2 cos x minus 1. How do we prove identity? You must first identify the side that you're going to prove with, right? So we can see that this is quite complicated. We can simplify it and actually prove that it's the same as that one. So we are going to say we are choosing our left hand side to prove with, right, which is minus 2 sine squared x plus cos x plus 1 all divided by 1 minus cos 540 minus x. Okay, so how can we solve that now? Look at this. Below it's expressed in terms of cos, and above there is some cos there, right? Meaning that actually we can now change this sine squared in terms of cos, because also our answer is in terms of cos, right? So how can we change sine squared x? We know that there's an identity that says sine squared x plus cos squared x is equals to what? Is equals to 1. Then if we're solving for sine squared x, it's gonna be equals to 1 minus cos squared x. Okay, so we can use that identity. We'll say minus 2, our sine squared x we can replace by 1 minus cos squared x. All right, plus what? Plus cos x plus 1 all divided by 1 minus. How can we simplify this? We can actually reduce this one, right? How can we reduce? They have given you an angle of 540 degrees. So if you got an angle of more than 360 degrees, what you do from that angle, you subtract 360 degrees up until you get an angle that is less or equals to 360 degrees. So what we're gonna do is 540 minus 360 degrees. You reduce it up until you get an angle that is below 360 or that is equals to 360. So when we subtract 360 from 540, it's giving us what? 180 degrees minus x. Then it's fine, right? Because this one is what? It's 180 degrees. All right, so we've reduced it, it's fine. Then we can go and simplify. Minus 2 times 1, it's going to be minus 2. Minus 2 times minus cos x is going to give us positive cos squared x, right? Plus what? Plus cos x plus 1 all divided by 1 minus. What is cos x? I mean cos 180 degrees minus x. We know that 180 degrees minus x is found on the second quadrant where we find sine, meaning that our cos has to be what? Negative, because it's not in its position. So be very careful with the sign. They've given you minus here. Don't make that mistake to say there's the minus for the formula, but our cos, when we reduce it, it's also going to be negative x. So we just put it in bracket to avoid making mistakes, right? So then we can go and simplify this quickly. So it's going to be equals to minus 2. We can add it with 1. Is going to be minus 1. So it will be cos squared x plus cos x minus 1 all divided by what? Negative times negative is going to be positive, so it will be 1 plus cos x. All right, so what can we do now? We can actually factorize on top, right, on the denominator, so that at least whatever that is on the denominator can cancel with whatever that is down, right, so that we can finally prove this. I think I forgot 2 here, right, because minus 2 was multiplying with 1 and minus 2 was multiplying with cos, so it must be positive 2 there, right? So it's 2 cos squared x plus. So let's go and simplify. So this is the same as you're having 2 y squared plus y minus 1. So how do you factorize it? So open 2 brackets, you'll have 2 cos x plus 1, probably let's put it like that, cos x. Let's see how it will go. So 2 cos 2x must multiply with 1, right, and that is positive. This one must multiply with 1, that is negative, so that it can be 2 cos x minus cos x, which will give us positive cos x in the middle. So that's basically how you factorize, right? So this must be positive, then we'll have 1 plus what? Cos x. Okay, can you see something now? We have like terms on the numerator and the denominator. we can cancel out cos x plus 1 plus 1 plus cos x. Then our left hand side will be equals to what? 2 cos x minus 1. Alright, so now we can finally conclude actually even the right hand side is 2 cos x minus 1. So this means that our left hand side is equals to what? Right hand side. Then we have proven. Alright, let's lastly conclude with our 5.3. We are given sine 36 degrees is equals to root of 1 minus p squared, right? And they want us without the use of a calculator to express each of the following expression or trigonometric ratios in terms of what? Of p, right? So what's the first step that you do when you're given such a question, right? Obviously the first step is for us to go and draw a what? A triangle, right? On a Cartesian plane, right? So where is 36 degrees? We know this is 0 degrees, 90 degrees. Obviously 36 degrees is on the first quadrant, meaning our triangle, right angle triangle, will be on the first quadrant. We have 36 degrees here, right? So it's advisable that we also get that angle there. You use some angles of a triangle, right, to get it. So it will be 180 minus 36 minus 90, which will give us what? 54 degrees. Okay, so after this you are given that sine 36 is equals to what? Root of 1 minus p squared. And we know that sine is actually the same as opposite over what? Hypotenuse, right? Obviously our hypotenuse here is what? Is 1, right? Because so that it can give us root of 1 minus p squared. So what is our opposite? Our opposite is root of 1 minus p squared. Our hypotenuse is what? Is 1, right? So then we have a duty of going and calculate for what? For x. And how do we calculate for x? Using what? Theorem of Pythagoras. Okay, so that's the first step that we do. So we're going to use theorem of Pythagoras. Hypotenuse squared is equals to the sum of the other two sides squared. And this is what Pythagoras state, right? What is our hypotenuse? 1 squared is equals to, we are looking for x. Our y is root of 1 minus p squared, right? So it's going to be 1 is equals to x squared plus root of 1 minus p squared squared. The root will cancel and we'll be left with 1 minus p squared. So when we transpose 1 minus p squared to the side, it's going to be minus 1 plus what? Plus p squared is equals to x squared. 1 and 1 cancel. You'll be left with x squared is equals to p squared. When you apply the square root, x is going to be plus or minus what? P, right? So obviously our triangles in the first quadrant, meaning our x will be positive what? Positive p, right? So we can now go and calculate and express the rest of those trig ratios in terms of p, right? Okay, 5.3.1, they want us to express tan 36 in terms of p, right? What is tan? Tan is the same as what? Opposite over what? Adjacent, right? So let's go and check what is our opposite. Our opposite is what? Is square root of 1 minus p squared. What is our adjacent? Our adjacent is what? Is p. So that will be our tan 36 degrees expressed in terms of what? In terms of p. All right. 5.3.2, they want us to express cos 108 degrees in terms of p, right? Obviously we have to use our triangle in order to do this. So how can we express cos 108? Now the problem is the angle that we are given here, it's not inside our triangle, right? And they like doing this a lot. So they want you to think of the ideology of a compound angle. If maybe we add these two angles in a triangle, can't we get 108? Or rather they want you to think of the idea of what? Of double angle, right? If maybe they have doubled one of the angle there in order to get that one of 108. So that's what you think of if you are given an expression where the angle is not inside the triangle. You must think of maybe compound angle identities, maybe adding those angles inside to see if you can't get 108, or rather think of double angle identity to say, what if we double one of the angles inside the triangle? Won't we get that one? Then you can be able to solve it and express it in terms of p, right? So let's go and add 36 and 54 and let's see if we can't get 108. Definitely not, right? So 36 plus 54 is giving us, let me check it quickly, it's giving us 90 degrees. So definitely not equals to 108, right? Let's see, which angle can you double probably to get 108? Obviously is what? Is 54, right? So if we say 54 times 2, it's going to give us what? 108, meaning that we can rewrite cos 108 as what? As cos 2 multiplied by what? Multiplied by 54 degrees, right? Then after doing this, we know that we can exchange this and use it a double angle formula, right? Of cos or of sine if you want any. So because we have 3 double angle formulas of cos, right? So remember, if we have cos 2x, it can be changed into 2 cos squared x minus 1. It can be changed into 1 minus 2 sine squared x. It can also be changed as cos squared x minus sine squared x, right? So we have 3 of them, so you can choose any of them. So I'll just use the one for cos, which is 2 cos squared. Our x here, it will be what? 54 degrees. So 54 degrees minus 1. All right, so now we can go and simplify 2. What is cos 54 degrees? Now we have expressed in terms of an angle inside the triangle. 54 degrees cos 54, it will be what? Adjacent, which is this side, root of 1 minus p squared over what? Hypotenuse, which is 1, right? And this is squared because our cos 54 is squared. Then we say minus 1. According to that formula, we can simplify. It's going to be 2 into that one over that one will remain root of 1 minus p squared. When we square, the root will go away and we'll be left with 1 minus p squared minus 1, right? We can simplify this. 2 times 1, it's going to be 2. 2 times minus p squared, it's going to be minus 2 p squared minus 1, right? Group the like term. 2 minus 1 is 1 minus 2 p squared. That will be what? Our final answer. So that's basically how you solve this kind of problem. Otherwise, great solve. Thank you very much for joining. Thank you for watching this session. Otherwise, let's meet on the next session. Otherwise, that's all for me, and goodbye.